All right, hello. It's wonderful to be here. So this is my talk called Nightmares Untangled, which is a selected short stories on supply chain attacks. So my name is Grace. I work on the detection and response team at Google in Sydney. I'm actually doing a joint talk later today with Chris, who is my manager, and we'll be talking more about exactly what I do at Google. So hold tight for that. I'm from New Zealand originally. We have a population of 4.5 million, which I think is roughly the equivalent of one suburb in Cairo. So people typically know us from things like Lord of the Rings and having pretty mountains and stuff like this. I also like to do watercolor painting in my spare time, and I also recently organized a small conference called PurpleCon. This is our page. We focused on talks for developers and defenders, and this was right before a bigger HackerCon called KiwiCon in New Zealand, which is kind of like our small version of DEFCON, sorta. Alright, so people in Egypt have had a profound effect on all of society, from inventions in art, science, and engineering to single-handedly causing thousands of years of cat versus dog debates. Cat memes, which populate around 55% of the internet, wouldn't have been possible without you. So thank you for that. I'm very thankful to be here. Before coming here, I did a little bit of research into the security scene here, and it was fairly quiet, but it seems to be that there's lots of hackers who come from Egypt who are really killing it in the bug bounty scene, which is awesome. And there's also been some interesting projects that have stemmed out, but it was still a little bit difficult to find something. So I'm really excited that something like BSides Cairo is happening here. It's incredible to share knowledge and meet people who are really passionate about security. Here you can learn about different kinds of attacks, share ideas for building better defensive systems, or perhaps you can gain an appreciation of this field, which might be adjacent to one that you're currently in. So, going to conferences has been a really big part of the community for me. That's kind of how I got into security. The first conference I went to was KiwiCon, which I mentioned before, and that really inspired me to change into computer science and then eventually get into security. The world is becoming ever more connected and simultaneously divided. Technology is moving at a rate which we can barely keep up with. Information security is crucial to keeping people safe going into the future. Sometimes it can be hard for us to feel like we are contributing, especially if what we're working on is small projects or working locally or studying. But what I'd really like to show you today is what you work on does matter. And I'm going to share some stories with you. Some of these stories may be familiar. Some of them are funny, some are a little scary. Each story highlights an important problem in securing our software supply chain. So, we're going to go into story number 1. This is about NPM, which is a Node framework package manager, and it tends to favor small, often single-purpose libraries. And I'm going to talk about one package in particular today. I know that there's been a bunch of different kinds of security incidents that have happened with NPM, but there's one in particular that I'd like to highlight. And this is the mail parser package. This is used for handling emails. But one day, a simple little function appeared inside of it, and this was called the getCookies function. This function was not like the rest because it had some odd functionality. Of particular interest, there was this one line of code. So let's take a closer look at this. Here we can see that it accepts some data delineated by GHI. Upon further inspection of surrounding code, which I've omitted from this presentation, it was figured out that it was taking a command and some arbitrary code, the command specifying what to do with that code. So in this case, it might have been like loading in the code, executing it, or clearing the buffer. And that code could be absolutely anything. Now, who could have put this code in here? Get cookies is a popular function. Everybody uses it every day. And you might be wondering, which company makes get cookies? How many millions of dollars do they make per year? What's their skyscraper office like? Who's their CEO? You might think it's a Metacorp, but actually, it's just this guy. Dustin, 87. So unfortunately, Dustin is just a stock image. It's a GitHub account created using the stock photo, and it built 3 modules which they released as part of Mail Parser, one of which contained that backdoor. Now let me just show you what the web pager for Mail Parser looks like. So this is Mail Parser, the library that contains get cookies. This page doesn't really look that interesting, right? We can see that the library is getting around, 60,000 downloads a week. That's quite a lot. And there are 200 other libraries that actively depend on this one. But the thing is about this library is that it's actually deprecated. That this isn't the library that you should be using. But how would you know that this isn't the right library? It doesn't say deprecated anywhere on the page. It also has this weird thing called node mailer here. What even is that? What does it mean? But this is the correct library. This is the one that is not deprecated, being actively contributed to. If you notice, they look very similar. Like, how would you know the difference? We can see that it's got an order of magnitude more people who download this every week, and it has almost 2,500 libraries that depend on this one. So it's really hard to tell sometimes what it is that you should be using. There's also a bit of a plot twist. The backdoor code was never actually called. It was put into get cookies, but nothing ever did anything with it. But why would the hacker just have put it in there and never use it? Maybe it was just to build trust with the project first. Maybe it's because they wanted to just see if, maybe people would keep using it. Like, how many people would continue to download this library with the backdoor in there before it got noticed? Maybe it was their first time doing hacking, and they were just a little too bashful to run the backdoor in their first time. So, in summary, the bad code was online for a few weeks, and the potential impact was at around 60,000 downloads a week. Maybe you would get more than potentially, almost 200,000 backdoored machines. But it was never actually called. And this is kind of roughly what a diagram of this kind of looks like. You had the GitHub account, you have NPM going straight into whoever's machine who's going to be building this package or the app that's using it. In summary, we would say that the impact of this is pretty small. It's interesting in the sense that maybe if it was put in node mailer, it could have had a lot more damage, right? If it was in there for a couple of weeks, it could have been almost 1 million downloads where people have the backdoor on their machines. So essentially we got lucky in this sense because the hacker didn't press the big red button that said, do the hacking please, put the arbitrary code on people's machines. Alright, so we're going to look at story number 2. So this is for something a little bit more fresh. There's lots of people who have access to change code to Linux, which is pretty exciting. It'd be a shame if somebody were to do something to that. Take advantage of this. If you want to relive the 90s, you can talk about Linux Mint on a forum where you can go and you can talk about all the latest features, and you might know that forum software is notorious for having devastating security bugs. Unfortunately, an attacker also knew this. an attacker took over the Linux Mint forums, specifically an account of an administrator. Very conveniently, this was also an account that could upload new versions of Linux Mint, make modifications to the documentation, and download an entire copy of the forums in database. So useful, so helpful to have an account like this. There's also this very handy message right here where you can fork and patch the source code and do absolutely anything with it. So what the attacker did is they put in a Nolan backdoor called Tsunami. Tsunami connects to an IRC channel, which you can configure, and it will just sit in there and it will wait for commands. Usually this is used for denial of service attacks, which is where it got the name Tsunami from. So they uploaded this bad ISO, this bad Linux version that they created, and they put it into every place on the forum where a version of Linux Mint could be downloaded. They really took this open source thing too far. Not only that, the checksums were changed to match the malicious ISO. But do people really even check these anyway? You know, we live in a fast-paced society where we are too busy deciding which celebrities we don't like anymore and scrolling through our phones to even check checksums. But you know what they say? Check some yourself before you wreck some yourself. I'm so sorry. So how do we know what happened? So we know all this information because the attacker who did it confessed their sins to a journalist, of all people. This was done by a guy called Peace, who lives in Europe, and no other affiliations to hacking groups. They've also offered private exploit services on secret marketplace websites. So he was on the forums for 1 hour, where he managed to get a few hundred shells from 1,000+ installs. So this is a very popular distribution of Linux, like to have control for 1 hour and to get that kind of result. But what about the forum dump? What he did is he sold these on the dark web for around $85 per download. This was also added to Have I Been Owned? I'm not sure if you're familiar with this website, but this is like a really helpful place to look up. You can put in your email address and it will say what websites have had their databases dumped that contain that their email address, as well as what data was dumped as part of this. You can put in your own email address in there, or, somebody else's. Nobody's stopping you from doing that. So this had like a bunch of accounts that were added. So in summary, we had 71,000 accounts that were added. How many of these were reused? How many of these passwords were reused? The Linux Mint OS was backdoored, managed to get hundreds of shells within an hour, but fortunately it only lasted that long, and I think the forums were taken down for a weekend after that to get everything rebuilt. It's only managed, Linux Mint is not managed by that many people, so it took a lot of work to recover from this attack. So that's kind of this is a simplified version of what this supply chain looks like. We have the code that is open source, we have the forums which are distributing these ISOs, we have the malicious ISO, and we can see where the attacker attacked this project. So, was it really a tsunami? It was more like a scary wave. It was large but very short-lived in this attack. Next we have story number 3. And this is with Mega, which is a platform for storing and sharing content in the cloud. They have a Chrome extension, and it looks something like this. This is a screenshot from the Chrome Web Store, and it happens to be made by this guy, who is a German guy living in New Zealand, my home country. Dunking on him is a cultural tradition. including by police. His mansion was raided for a few reasons. He was doing some like pretty bad stuff on the internet, and he's like got a big personality. He even had a movie made about himself, claiming that he is the most wanted man online. Is he the most wanted man online? We don't know. Only the audience can say. Anyway, an attacker got hold of Mega's Chrome extension. What they did is they grabbed the source code, again, which happened to be on GitHub. I'm not actually dunking on GitHub. It's just a coincidence that these projects are using GitHub. This can also happen with proprietary code. You may not hear about it because it's proprietary. I mean, there's like some rules that are going around, like laws that are now trying to make corporations like talk about times when they do get hacked and stuff like this. But I think typically with like open source projects, we're also maybe more likely to hear about it. So what they did is they hijacked the developer's account, and then they released a malicious version of the Chrome extension. And this has, at the time, it had 1.6 million people who had this installed. So if we go back to here, we can see that it's now got 1,800,000. So that's like a lot of people who are have this installed. And one of the things that it did is that they specifically looked for passwords or credentials for these websites. Where did it look for the creds? It would often look for sign-in boxes like this, or it would even look in like URLs for any traces of like logging in, and then in the packets that were being sent, it would look for any variables that were called like names that remotely look like they were to do with signing in places. They'd just try and grab everything that they could. It would also send all the interesting stuff that we find to this address, which is hosted in Ukraine. It contained crypto mining, because, you know, why not? Always worth putting crypto mining into everything that you can these days. It seems to be the hip new thing for attackers to do. Maybe right now, not so much, since it's taken a little bit of a plunge, but who knows? We'll see how that goes. It would also try and steal private keys for people's wallets, but it did not look for mega credentials itself. It actually just didn't care about that side, which makes you think that maybe this was financially motivated. If they're, you know, have a miner and they're looking for wallet keys. That was a weird sound. So we think that this is probably financially motivated. But for this attack to work, the user had to agree to new permissions. Whenever you change the permissions in a Chrome extension, you have to explicitly say what you are looking at. So, you know, when you click this button, it's like add to Chrome here, and then you get a screen that looks a little bit like this. And you're like, wow, drink water reminder sure really wants a lot of things from you. So it really pays to pay attention to these. Alright, so they have a blog post where they talked about this compromise. And they had this line in here saying that they were investigating what happened with this attack, and I thought that was really interesting. So I was hoping that, you know, when I clicked next to have a look at the next blog post that they published, that maybe there would be more information about this. But instead, 1 month later, they were adding two-factor authentication. So maybe there's a connection here between what happened with their account being compromised, and also the need to have better authentication. So in summary, we had 1.6 million affected users where their passwords are maybe stolen. And a clean version was released after 4 hours, which is pretty good. Like, that's really fast response time. But you still had a lot of people who were potentially affected by this. And also, when you're trying to get 1.6 million people to change their password, it's a little bit like trying to have an argument with them and trying to convince them that Android is better than iPhone and that everybody should just calm down. Like, it's so hard to get everybody to change their password. And this is like, change every password on every site that you may have logged into while the malicious Chrome extension was online. So quite a challenge. Definitely annoying for many people. So in summary, we would say that this was like pretty impactful, but not the end of the world. So this is the final story that I'm going to talk about today. This is also maybe one of the scariest stories that we've had more recently. And this is focusing on NotPetya. Sorry, that's a little bit hard to read there. So I'm going to start with the initial infection vector for this. So NotPetya, just to summarize, this was a ransomware that spread out throughout the world, and it was like pretty devastating. And we'll get a little bit more into what this actually did and how it worked. And it started with Intellect Services, which is a company based in Ukraine. So MEDoc is used by 80% of companies in Ukraine. It's got around 400,000 clients. It is a tax service, so essentially it's allowing people to file like tax returns and tax claims and stuff like this, I believe. And it's specifically made for Ukrainian businesses. So this app will allow people to send and discuss financial documents between internal departments, as well as file them with the Ukrainian state tax service. So pretty important software, but also not particularly interesting in a way, you know, like it's just like maybe not something that really sparks joy, but just something that everybody has to use. All right, so the bad person, whoever that was, they managed to get credentials into Intellect Services organization. So maybe they did this by phishing. We're not really sure. They had a look around at the rest of the org. They were scraping creds along the way, trying to get whatever information they could. They kind of sat there and observed for a while. They also found the MEDoc update service. So this is a server that whenever this company wants to update their software, this is how they deploy those updates to all of their clients. And they added a backdoor to this accounting software. And they pushed this through the legitimate update server. So this server didn't actually use a command and control server in the way that malware usually does. Because they had compromised the organization, they could just sit and watch the legitimate update server. And what they did is they would gather information about the computers that the software was installed on, and they would bundle up this information inside of a cookie, and then they would send it back to the update server. So this is not very suspicious looking at all. If you are a security engineer or a sysadmin on a company and you're looking at outgoing traffic, if you're looking at it at all, this is not going to really raise alarms if, you know, it's sending information back to, where the company that is, maintaining the software, then that just, doesn't really raise alarm bells. So they did this for a while. They just collected information on people's computers, like just what software was installed, like what version of their machine did they have, and was it patched, and all this kind of stuff. And then eventually, it sent the malware. It sent the bad packet of information. So inside of this, it had a few commands inside of their backdoor, one of which was to install this like script or the malicious payload of this malware that they wanted to send out, and it would install on that machine, and it would be given a special name. It would run for a little while, and then it would attempt to delete itself. So let's have a look at what they actually sent across, because this is really interesting. So here we have that script. And what it does is it will grab any credentials left in memory using like a lightweight credential scraper that's sort of similar to Mimikatz. And this is part of the way in which they would try and spread through the rest of the network by being able to get information. In fact, it used a few different ways to try and spread across the network, including the forbidden NSA hacks, which, if people are familiar with, if you've ever done like OSCP, hackers love Eternal Blue. Thank you, NSA, for giving us such good exploits to use. So it would use this External Blue and External Romance as a way of getting around. It would also use PSExec, which is a lightweight telnet replacement that lets you execute processes on other systems, complete with full interactivity for a console, and it also used Windows Management Instrument, or WMI, which is used for consolidating the management of devices and applications on a network from a Windows computing system. So those last two ways of getting around a network are like legitimate Microsoft tools that they have built to help you manage devices on a network. So this malware used these 4 different paths to spread across the network. And then, once it had done that, it would overwrite the master boot record, or which is like the first. So that would be the first few segments of your bootloader, essentially. And if that was unsuccessful, then it would overwrite the first 10 segments of your hard drive. Interestingly enough, it also looked to see if you had Kaspersky antivirus installed, and if that was, then it would also overwrite the first 10 segments of your hard drive. It then had a ransom that asked for $300 in Bitcoin, but this was a little bit of a trick, right? They're overriding these like very crucial components of your computer, and they did that before encrypting everything, which is like maybe a little bit suspicious. It's made worse by the fact that there was a timer installed. So after a period of time, regardless of what you tried to do, the computer would reboot itself, which obviously, since now it's overwritten like the bootloader and or your hard drive, it would not successfully boot, and the only way you get your machine back is if you factory reset it. There are other interesting things about this, like that there was no command and control server. This malware was just distributed, but it had no way of talking back to the original attacker. And this is pretty strange, because typically with ransomware, the attacker wants to be ready and available. I believe even some groups or organizations that are running ransomware campaigns, they may even have like call centers and like have really good support because they want you to pay the ransom, right? So they'll very helpfully make sure that you can get your computer back again, because that's a good way for them to get money. So this is a screenshot of what the NotPetya looks like. It has a thing here saying like decrypting sectors, but this is lies and slander. You could not get your machine back if you had been infected with NotPetya. It was made purely for destruction, which is really interesting, right, as a campaign. Like, it's an interesting choice to make. So this malware spread like wildfire. And And I'd like to talk a little bit about an example victim. And this is Maersk, which is a shipping company. There was a really awesome write-up by Wired magazine, and the information that I'm telling you comes from that article. I really recommend reading it because it's super interesting and goes into a lot more detail. So this is a company that's actually based in Copenhagen, and it's, I think, the world's largest shipping conglomerate. They had an office in Ukraine, which used ME-Doc. Globally, they have nearly 80,000 employees. They have 574 offices in 130 countries around the globe, and they account for around the fifth of the world's shipping. So they had around 150 or so domain controllers, which is the way that they, manage their accounts globally. And these all got knocked out by NotPetya. This spread across their whole organization. It took over every single one of their computers, except for one. They had a domain controller in Ghana, which just, I think, 1 or 2 weeks prior had been knocked offline by a power cut, and it just hadn't been put back online yet. They just hadn't got around to it yet. So this was sitting in Ghana, and the restoration effort for NotPetya was happening in England. So they had to get the server from Ghana. They had a staffer from the UK fly to Nigeria, where they met another staffer who wasn't able to get a visa in time to fly to the UK, and they met in the middle, handed over the server, which was then flown back to London for the restoration effort, which is just incredible. They were really lucky that they had this, but maybe now they're thinking a little bit differently about how they organize their network. So while this was happening, while their networks were shut down, they had ships that couldn't leave because they didn't know where they needed to go. They had trucks that were all backing up. They had goods that were spoiling. And they had to pay back people for goods that were lost and damaged along the way. So this cost Maersk a huge amount of money. I think it cost them 106 million or something like this, just from NotPetya knocking out their networks. Globally, it's estimated to have cost around $10 billion for organizations where similar things have happened. So it took a really long time for companies to resume functioning. So the impact of this was huge, right? This was really scary for a lot of people. It really made us think more about what is happening in our software supply chain. What do we trust? Where are these attacks coming from? What will the future be like? So lots of people were asking a lot of these questions, right? So I want to talk a little bit about attack surface area to get a general idea of what a software supply chain attack can look like, or what it might look like to an attacker who is considering this type of attack. So you might start with your computer. You're a developer in an organization. You install some tools that you use, and they each have libraries that they use. And these often reference each other, different libraries are used by lots of different packages. And then you have multiple people who are working in your organization that have the same sort of thing, but they might have a little bit more variation. They might have some other software that's installed that you don't. But the graph kind of roughly looks the same. And this might be your organization, and these are different organizations that are talking to each other. And this is kind of similar to maybe what a physical supply chain would look like. Say if you had a pharmaceutical company, courier company, a hospital. You can see that these are pretty important organizations, and each of these are filled with computers that have lots of different stuff installed on them. And maybe your project is just sitting right there on one of these people's computers. So essentially, you are here. This is all malware, probably. So for an attacker, this is like a pretty exciting thing, right? You can attack any node in the graph and then get access to other nodes through transitive trust. And the more machines that you hack, the more progress you make, the better it feels. It's like really rewarding when you're making such great progress owning an entire network. But what can we do about this? Do we just unplug everything? Probably not. Maybe it'll be a little bit more like this. We just don't trust each other. But there are some things that we can do. We can reduce or eliminate risk from each node in the chain. We can increase cost for attackers, and we can increase risk. And this is like a huge effort, right? This is something that is more than what one person can achieve. But we really want to have a look at each part of these graphs to see what we can do and how it might make a difference. So if we go back over the stories, we can look at examples of ways in which, and these are just simple ways as well, fairly simple, right? Of being able to improve some security that might have made those attacks difficult to do. So, for example, with the NPM, they could have had a code review process where somebody else was checking the code. They could have made sure to be using two-factor authentication, where if you are a developer on a project, then you have keys that you can use to sign your work and make sure that it's coming from you, like a verified developer. You can also have a look at monitoring for your own machines or your network, where you look at what outgoing traffic is going. So these things can take a while to build, but these are things that can be pretty helpful in trying to prevent these that kind of attack. Then we also have Linux Mint, where again, if the forum administrator had a security key, like one of the physical YubiKeys type thing, then that could have been used to verify his login so somebody couldn't do it remotely. They could also have reproducible builds, which is a way of compiling a project in a way that every time you compile it, you ensure that the resulting binary is the same. And so it can be reproduced, and making sure that you're trying to verify there isn't malicious code in there. So this is also a complicated task. Debian has been doing a lot of really interesting work in this space. Then we have the Mega Chrome extension. Again, having two-factor authentication would be better. Also, signing of their extensions is a good way to do this. So they did, the way that Chrome works is that it does auto-signing, which is not really ideal, because really you want to make sure that the developers who are working on this have the control over their Chrome extensions. So perhaps that's something that we at Google can work on, right? The other thing is you panic when you see permissions. When you see those permissions, if it's asking for your firstborn, then just do not let it have control over your computer. For NotPetya, those attacks, the NSA, Eternal Blue, if your machines are patched and up to date, then it should not be possible to use those. However, as noted, it did use other legitimate ways of spreading through a network, using Microsoft's very own tools to do that. So system monitoring is also important, and having isolation too. So making sure that if one part of your organization gets taken down, then other parts don't go down with it. And things like backups, we talk about backups all the time, right? But it's really important that we take the time to do that. I guess you could also try not to have NSA 0 days in your stuff, I guess. But that's pretty hard as well if you've got 0 days, right? So one thing to think about is who uses your software. Maybe you don't feel like people, your project is that important, but maybe people who are using your software might be targets. And that might be something to think about. Who are your clients, and would anybody want to hack them? That kind of can maybe help you think a little bit more about maybe, or at least inspire you to think a little bit more about like your own security practices. We've got to remember that we're all in this together, right? Like, this is a really complex environment that's continuing to get ever more complex. And we really want to work with each other and making things better. Attacking other people is just like, it's not the way to go. We really want to support each other in this. Except at least one of these people in the graph is probably a hacker. So, thank you very much.